In this video, we will see about the fundamental concept in data structure, that is linked list.
Hello everyone. Today we will presenting a case study of the fundamentals of data structure, that is linked list and their types. We are using a dynamic data in our generation. So in arrays we are have a fixed size of data. So it is not efficient for the users. So we go for a linked list. In linked list it is efficiently to store and manage the data. So it uses node to store the data connected through the pointers. So we will be facing many real-time problems, and it is used in many real-time applications also. So we will see about the case studies.
One statement of this case study includes we are going to build a text editor. In the text editor we will be storing the elements. So while storing the elements we will be adding or deleting it. So when we do these operations, the elements will be shifted. So it causes a problem. So we are going to rectify this problem in our text editor.
We are using linked list implementation. What is linked list? Linked list is a data structure, linear data structure, in which each element is stored in a separate row, which contains data and pointer. This allows the elements to store non-contiguously. There are 4 types of linked list: singly linked list, doubly linked list, circular linked list, doubly circular linked list. In linked list, there are 2 parts, namely data and the pointer. Data is the actual value that is present in the list. It contains the meaningful content that is required for the linked list to do the work. Pointer refers the next node that is present next to the one particular node. It stores the information or the location of the next node that is present next to the first node. Usually, the last node contains a null pointer in Python and also in Java, which represents the end of the list.
So now let me tell the 4 types of linked list. So there are singly, doubly, circularly and double circularly. So to talk about singly, actually it contains a node which points to the next node. So in one node contains data and pointer. So it's to talk about traversal in singly linked list. The traversal will be in single direction. So these can be used in scenarios like queues and stacks. So the second one is doubly linked list. So to talk about doubly linked list, actually it contains one data and 2 pointers. So the 2 pointers are next and previous. So one pointer will point to the next node and another pointer will point to the previous node. So this will be used in many scenarios like browsing history. And the third one is circularly linked list. So in circularly linked list, it's same like a singly linked list. The one thing differs is the last node will point to the first node, and it will be used in round robin scheduling and playlist loops. And the last one is doubly linked list. So to talk about doubly linked list, it is the combination of both doubly linked list and circularly linked list. Actually in this the last node will point to the first node and the first node will be points to the last node, and then this will be used in media playlists and so on.
So the solution of this case study problem includes, so we have developed a linked list which performs efficiently and it reduces the time also. So while executing this linked list, we will be storing every characters in a node. So we don't want to shift the entire contents of the while deleting or inserting a character. So the real applications of this linked list includes web browser. So in web browser, while clicking next or previous button, the linked list plays a major role. And in operating systems, we will be processing and managing the queues. And in, mainly we will be using in Spotify playlist. So when we are skipping or moving to previous music, the circular list will be playing a major role in this. And in process memory system, it will be playing a major role.
So here are the pros and cons of this case study on linked list based on their case study text editor. So firstly we're going to talk about the pros of this case study. The first one is it is dynamic memory allocation. We all have known that linked lists are used for the dynamic memory allocation. So we have to store and data efficiently and manage them by using the linked list. So
next one is efficient insertion and deletion. Unlike the arrays, it is efficiently insert the element, especially in the middle or a last or a beginning position of this linked list. And here are the cons of the case studies is more memory usage. It requires more memory space because if we have only one data or element in the array a list, but we have to add the pointer because we are known that list have two parts, data part and the address part. If we don't have any second data, we have to add the pointer in the first node. So it requires more memory usage, and it is a slower access time. If we have to search one data or element in a list, we have to traverse from the head node to the last node to find the data or element. So it requires more time to access the data.
So to conclude, linked lists are powerful tools for managing dynamic data. So it allows faster insertion and deletion, and also it reduces the memory overhead that are associated with array. So choosing the right type of linked list will help you to improve your application more efficiently.